Hi, I'm Josh, and welcome to Electronics Unscripted, where we take an unscripted and intuitive look at topics in electronics. Today, what we're going to be doing is walking through the process of getting a PCB design that you developed in KiCad submitted to JLCPCB for manufacturing. And there are a number of plugins that we're going to use to facilitate this process. So I'm going to walk you through what each one of those plugins are, how they work, and how they help in the process. It's not a perfect process by any means. I come from Easy EDA, which is, I don't know, it's about as perfect as you'd want to get if you are going to submit things to JLC PCB. But one of the downsides of it is that you're really locked in to JLC PCB. You really can't submit a design anywhere else. You can't take your design and export it and send it to PCB way. It's not very easy to share your design. So if you wanted to put your design up in GitHub or something like that, that's not really a great way to do it. So I was attracted to learning KiCad. I'm still learning. I'm by no means an expert in KiCad. I'm good enough to be dangerous. I can mostly do everything that I used to be able to do in Easy EDA, but I found it to be incredibly difficult to find the components and the footprints and the symbols and so forth that you need in order to make that process transparent and smooth. This video will walk you through the individual plugins that you need and then the process that you need to follow as you develop your schematic and your PCB layout to make sure that everything's going to flow smoothly when you finally go to submit it to JLC PCB. So what we're going to do is we're going to start out in KiCad and walk through some of the plugins that you need to install to be able to take your project fully from schematic all the way to production. So here's the list of plugins that I installed to support taking your project to production with JLCPCB. So the fabrication toolkit is important. What this does is it makes sure that, for the most part, when you go to export your Gerbers and your placement files and your bill of materials, they're properly formatted for JLCPCB, and you're not going to have any problem with them. In-part GUI is, I'm assuming that's a misspelling of import. It kind of barely works, but it's a really good tool for if you can find the LCSC part number, the website, you can enter it into import GUI, and it will pull down the footprints for it. It will pull down the schematics for it, the symbol library for it, and the 3D library for it. The last plugin is the JLCPCB KiCad library. This is super cool. What it is somebody who's gone and done all this work for us for most of the basic or preferred parts in the JLC PCB library. The preferred parts, if you don't know, are the ones that are going to be cheaper. If you don't use a preferred part and you're using the economic assembly, and again, this doesn't matter if you're not doing assembly. If you're assembling it yourself, another business. I don't assemble things myself. I usually have them do it for me, and I try to get the economic assembly. And if you do the economic assembly and you are not using a basic part, they're going to charge you $3 per part. Not per part, but per type of part. So basically per part number. If you get 10 of them, there's a $3 charge. And that's because when they're assembling these in their place and pick machines, they physically have to load in another spool because, it's kind of a unique part. And it's very unlikely that anybody else would be using that part in a run that day. So they have to stop their machine. They have to load in the spools with all of your parts and then go forward. Whereas if you get one of the basic parts, they can run your project through a bunch of machines that have all those preferred parts already preloaded. So it's much cheaper for them to do that way. So the JLCPCB KiCad library is the library that will basically make it so that you can just search for a 100 nanofarad capacitor and find a component that's going to be one that's in their inventory, one that's a basic component, so it's not going to cost you any extra, and then also it has the full symbol library, the footprint, and the 3D all pre-configured for you. So you don't even have to worry about it if you pick from that. And I'll show you how that works in a second. So the fabrication toolkit is available in the regular KiCad plugin library. That's awesome. In-part GUI is also available in the regular KiCad library, but there's a little bit of a hitch. At least in KiCad 9, it did not install properly for me, so I'll walk you through a possible fix for that if you have any issues with it. And then the final one, the JLCPCB KiCad library, you need to install that manually. So here's the GitHub for the JLCPCB KiCad library, nice description of it, and then it has the installation instructions for this. You want to add a custom repository in the KiCad manager. So if we come in here and we go to repositories and manage, you can see I've already added this one here. So you just want to click plus, add the repository and click OK. And then from here, you select that repository that you've installed, and then you can see the new JLCPCB KiCad library. And again, we've already got it here, but I think we can go ahead and do an update. So if you're running this for the first time, you'd be installing it. And then after you're done installing it or updating it, you say apply pending changes, and it's downloading. So yeah, so I've got the JLCPCB KiCad library in here as well, and we'll see how this works when we're picking parts in the schematic editor. Then we've got to do a little bit of support for impart GUI for KiCad. When it installs things, I'll show you the kind of the wacky GUI interface of this. So I think I need to go into my PCB here, and if we go to Tools, External Plugins, and we do Impart GUI, what I typically tend to do is I come down here and I give it a part number and do the manual import and do auto KiCad settings. So let's go ahead and get a part from them. So LCSC.com. LTV247, that looks fun. Let's go ahead and copy the LCSC part number. And if we put that in here, the library save location, so that's the current location of my current project. And I'm going to go ahead and say manually import. It says it imported that part number. It made a symbol, which is for your schematic. It made a footprint, which is for your PCB. Also did a 3D model. So if you take a look in our Finder, you can see, so here's the symbol. The footprint is in here, and the 3D models are in here. The next part is that we have to tell KiCad that there's something out here in these directories for it to use. So it doesn't know anything about this directory kind of by default. So there's two particular places that we need to go in KiCad to link it up. So this is really good for so if you don't have a basic part, if you know the LCSC part number, you can get a part into here. We're in the PCB editor right now, and from the PCB editor, you can go into your manage footprint libraries, and you can see the global libraries that we have. We don't want that. We want a project-specific library, unless you could manage this as a global library as well. So if you wanted to basically share all the parts you've ever downloaded from JLCPCB, but you'd have to be a little more careful to download them into an external directory, not into your project directory. For simplicity here, I'm just putting them in my project directory right here. So this is just going to be a project-specific library. The nickname needs to be EasyADA, spelled like that. If you use anything else, things will break. I'm not quite sure why that is, but it just is. That's that. You just configure it this way, and Bob's your uncle. Now we're going to go over to the schematic editor, manage our symbol libraries. So we click over to the project specific libraries, and here we see the EasyADA, and it's linked to the KiCad sim, the symbol library basically. And that's that. So basically now we can use those components in our layout. So if I wanted to place a symbol, so I just searched for the LCSC part number, and you can see in the EasyADA subdirectory there, we get this part. Great. So what we're going to do is we're going to start from scratch on this schematic. I've got an existing schematic here, which I took a little screenshot of, and we're just going to zoom right in on this. So this is a TI switch mode power supply. It takes 12 volts down to 5 volts. So we're going to go find that part in LCSC. And this is weird. In order to do, I don't think we can get to the plugin directory. We have to switch over to the PCB editor and then do tools, external plugins, import GUI. I'm not sure why that is. So we're going to give it that part number, manually import it. So we're going to go back to our schematic editor and go ahead and place this symbol, give it that part number, and there we have our part. Okay, so this is great. One of the things we're going to do, and this is a nice little trick, I didn't know this early on, but you can edit these symbols to have a layout that's more appropriate to kind of creating a clean schematic. So I can go ahead and I can edit this, click edit, and I can edit the symbol. And here we're in our symbol editor, and we're going to put L1 up here, V in, EN, put the two. Okay, great. So we've got this component, the switch mode power supply driver, with our pins in the right order. Go ahead and save that. And there, now we can see this component is properly configured. So we need a 10 kilo ohm resistor. So we're going to go ahead and place a symbol. I'm going to do 10K. Immediately we see PCM, JLC, PCB resistors. So these are all of the 10K resistors. And I think I'm just going to go for a basic 0603, which is a moderate size. I guess I could go for a bigger one, but I'm not going to be hand assembling this. So 0603 is just fine. Put this one in here. What other resistors do we have in here? We have a 100K resistor. So let's go ahead and do that again. Place a symbol, 100 kilo ohm. And we're going to go for 0603 again and place this roughly over here. We've got two of them. So there's our little voltage divider. I think that's it for resistors. Let's go ahead and get this 1.5 microhenry inductor into our project. So I'm going to go find it in our old one, and I've got the part number available. PCB editor, import GUI, and import this one, and place our inductor. So there we can see that. I'm just going to slide all this down so I've got a little bit more space here to work. So okay, there. And then I think all we've got left are all of the various capacitors here. And these should all be relatively standard capacitors. I need 22 microfarads. So I'm going to go to the place menu here, and I'm going to place a symbol. And we're going to go 22 microfarad. So we've got 603 and 803. And here we're going to go for the bigger ones because those are 25 volts. 0805, that's a big enough guy here. So we need two of those. And I think that's it. We're good to go. We're going to update our PCB for the schematic. I think we're good. I don't see any errors here. We're going to just go ahead and update this PCB, and it's just going to give us a pile of components to put in here. That's wonderful. Yay! And if we go ahead and take and view this in 3D viewer, I think it's going to complain about there's no board outline. I think one of the problems is it doesn't always link in the 3D components when you use impart GUI. So that's one of the other things I wanted to show you. So if you can go in and edit this footprint, edit 3D model. I think if we just edit this to be our project directory, tools, preferences, manage footprint libraries. So this is the, let's keep it that directory. Edit. Okay, so can we edit this? There we go. So that got it in there. So if I do this for the other one, I think that should fix him as well. 3D viewer, now I've got all of my components here in 3D. Wonderful. Great. So we're going to go ahead and draw a board outline for this. Let's just go ahead and make this like 100 millimeters by 100 millimeters, just to give ourselves a good amount of space here. Let's do view, 3D viewer. There we go. So anyway, I'm going to be looking at the layout that I created originally in EasyEDA. So let's go ahead and take a look at that real quick here. You can see the inductor here, the capacitors for the kind of the switching capacitors, the input, the output capacitors, and then all of the various wiring for the switch mode power supply controller here.
In the dark, where the shadows play, the beat drops heavy like night turns to day. Feel the bass pulse through the crowded space. Lose yourself in the rhythm, find your place. Euphoria's calling, bring the fire. Chase the night, let it take you higher. In the trance, we're all alive, aspire. Feel the rush, let the music flow. In this heartbeat, we let our spirits go. Lights are flashing, energy supreme. Riding waves of sound, lost in the dream. Every heartbeat syncs with the rolling tide. In this moment, let the music be our guide. Together we rise, no holding back. Chase the night, let it take you higher. In the trance, we're all alive, aspire. Feel the rush, let the music.
So we've got our 12 to 5 volt DC 500 milliamp buck converter, a little label on the top there that tells us what this thing is, and if we were ever going to use it, we could have some mounting holes. The next step is that we need to run our DRC and run our DRC. And wow, first time, 0 errors. It's not as if I ran this beforehand and cleaned anything up or anything. Actually, no, I didn't really have any errors the first time I ran it, which was amazing. All I had was I'd used some smaller vias, and some of the design roles were set for a larger via cutoff. So I had to decrease the minimum hole size and via size in the KiCad configuration so that it would allow it. And that's it. I do have quite a few warnings. Yeah, and these are, I don't know, it's not liking. I've got a mounting hole from JLCPCB, and it's just not liking something about it, but it's just a warning. And then there's some other warnings here that aren't terribly important. Copper sliver, I wonder what a copper sliver is. We're ready to send this off to production. There is one thing that I did want to talk about here. I made extensive use of this kind of finicky impart GUI. The problem is, after I installed it, it didn't work. And I don't know if this is just related to KiCad 9, but it just doesn't install properly. So I have a couple of notes here. You have to find the version of Python that's installed in KiCad. So I'm going to locate that in the applications folder. It's actually inside of the KiCad app. So okay, so I've changed into this giant directory here, and that might vary based on where you've installed it locally on Mac OS. And now we need to do /pip3 install easy EDA to KiCad. And we got a warning, but it installed. And it's just reinstalling it here. I've already installed it. But this is important. If you get an error message when you're using impart GUI, you need to run this command line to take care of that. And now the next step is to use the tools, external plugins, the fabrication toolkit. There's not a lot to this plugin. It does a lot of things behind the scenes. It doesn't really have a lot of interactivity to it, but I'm just going to accept all the defaults here. Yeah, so there are a couple of options here, but not a ton. What the fabrication toolkit is, and it doesn't say anything about JLCPCB, but it's designed explicitly for JLCPCB. I don't think it'll work for any other PCB manufacturing house. So we're just going to go ahead and do generate, and it then opens up this directory. And this is in the project directory. So it's a directory called production within your project directory. And then I think it's also got some backups here. But the files that it generates is a Gerber file. So if we open this archive utility, there we go. Let's take a look. So you can see all of the different Gerber files and so forth. I don't pretend to understand all this, but these are all the vector layers that the manufacturing house needs to be able to put together all the various layers of your PCB. I don't believe we use the netlist. Positions is very important. It tells the pick and place machines where to position the components on the board. And the BOM is a list of components. And very importantly, they're keyed properly such that JLCPCB will recognize the LCSC part numbers and get everything right properly, hopefully. The next step is we just go over to JLCPCB. Okay, we're going to leave all the default options here, and we're just going to upload our Gerber file. So we're going to find this production directory and just give it that zip file. And it understands how to download it, unpack it, and hopefully the plugin did everything properly to give JLCPCB everything that it needs to create your component. Yeah, so I've got this guy in here, and now if you are going to get it assembled, you click on assembly here, and hopefully economic is an option for you. Sometimes if you selected some things up here, I've had some cases where selecting a different color PCB or some different options up here made it so I could only get standard assembly. And you want economic assembly, especially if you went to the trouble of picking all of those basic components. And I don't really change any of the other options here. So as of right now, you can see over here, it looks like it's going to be super cheap, but wait a minute. It doesn't know what parts you're using yet. Then we're just going to click next, and we're going to give it our bill of materials. So this is the BOM from that production directory. And the CPL is the positions.csp. So this tells it all the parts and then the positions of those parts. And next step is it integrates them all together, and it's going to give us a parts list, bill of materials, and the cost. You can see we actually did a really good job of getting these basic components. So that means if it weren't a basic component, they would charge us $3 for every set of these. So for 10 of them or one of them, they would charge me $3. And then down here it says it doesn't know what those whole components are, which is fine. They are not part of, they're not actual components. They're just, kind of solder mask and copper and so forth. So they just get etched in. If there were any problems here, sometimes it will say, there are multiple parts who matched. Pick one or the other of them. Or sometimes it'll say it can't find a part, in which case you could search for another part. And that will work if the part that you find has the same footprint. If you find a part that has a different footprint, all bets are off. So like if you come in here and there's an 0805 capacitor that JLCPCB isn't recognizing, you can go ahead and pick another one and just do it from here. So everything here is perfect. And we can see how much things are going to cost. And this looks like it's going to be a relatively cheap board. And it's saying this project has unselected parts. That's not a real error. It's just saying those whole components, and there's no part for a hole. It's a hole. It's empty. There's nothing there. So this is the really important step, and it's a little bit scary. It mostly seems to get the placements right. Sometimes rotation is off, and badly off. So you need to look at every single component that you have where rotation is important and make sure that things are rotated properly. And also, it doesn't take this long to process. So we're just going to hit refresh here and hit next. Do not place. There we go. That was much quicker. It looks like we got lucky. We only have one component where rotation really matters, and that is our controller here. And it appears to, the dot there is lined up with the silk screen dot, and I think there's like a little bit of a virtual dot. So it does appear to be placed properly. And every other component on here, rotation doesn't matter. So our capacitors they're not electrolytic capacitors, so they don't have a polarity. So it really doesn't matter. So let's take a look. I think we're fine. But if there were an issue, say this were rotated improperly, you click it and then you hit the space bar. So you could have a situation where you come in here and you look at this and you're like, oh my God, that's horrible. It's fine. You just want to hit the space bar a couple times. Hopefully it's aligned properly, and you can see it's aligned in its silk screen just perfectly. So that's fine. You can also kind of nudge parts as well if they're not quite located in the right place. And now comes the real oof. So, total bill here is, so the PCB is $7.40, super cheap. The assembly for 5 of them is $30, which isn't bad. That's $6 a piece. Go ahead and save to cart. We're going to go ahead and go through the secure checkout and see what the real damage is, though. Ooh, yeah, there we go. So once we total up the shipping estimate and the customs duties and taxes, things get significantly more expensive. So yeah, so if you do the standard direct line, things get significantly cheaper, but it says carriage paid to a named destination, duty, tax, and the carrier clearance handling fees collected before or at the time of delivery at the destination. So I shipped one of my previous orders that way, and I still haven't gotten it. It's been 6 or 7 weeks. So I think it's lost in the ether. And so whatever amount of money I saved on that, you can see, oh, wow, that's half as expensive. I don't think you're going to save any money doing that. I believe that may have worked for me a couple times in the past. It does not any longer. So I would recommend going with the cheapest of the options here. So for example, if I select I think the cheapest here is the UPS Express Saver DDP. That is still doing the customs duties. It has a cheaper shipping, and that's going to be $89. So that's that. We went through the whole process of developing a schematic and a PCB in KiCad, picked all the right JLCPCB components, got all the footprints working, got all the 3D elements working for the 3D view of our board, and then submitted it. The bill of materials and the positioning all worked perfectly. Even the rotations worked great, and we all went all the way through to order. I can't be responsible for the shock and awe of tariffs and shipping from China, but you know, it is what it is. It's still a lot cheaper than anywhere else. So JLCPCB is a great option. They've done some wonderful work for me in the past, and I think I'll be continuing to use them in the future as well. This isn't any sort of a paid advertisement. I don't know that anybody watches me enough that it would matter. Uh, but yeah, I hope that this was helpful. Again, this was not meant to be a KiCad tutorial. There are a lot better ones out there than this one. Maybe it would be worthwhile to walk through that particular little project in detail, piece by piece, and show people how to build something up in KiCad. That's not what this was meant to be. That would be quite a bit longer and quite a bit more detailed, probably a lot more editing work as well. So thank you.